Welcome to Thermal Power Plant Engineering. Today we are discussing the topic Rankine cycle in thermal power plant. Rankine cycle is a model used for predicting the performance of heat engines. What are heat engines? Heat engines are engines that convert heat energy into mechanical work done. Okay. So Rankine cycle is an idealized thermodynamic cycle of heat engines, in which all losses such as frictional losses and heat losses are neglected, and here water is used as working fluid because of water is non-toxic and it has unreactive chemistry and it is easily available and it is low cost. And power generated depends on temperature difference between hot source and cold source. And we will discuss about the working of heat engine with a diagram. There will be a pump. This pump will pump the working fluid such as water from a low pressure to high pressure, and this high pressure water enter into a heating system. In thermal power plant, the heating system is boiler. In the boiler, the water is heated and the temperature of the water will increase, and phase change occurs. Dry saturated vapor is formed. This dry saturated vapor is applied to turbine where it undergoes expansion process, isentropic expansion. Then power is generated and this expanded steam is then passed through the condenser where it undergoes condensation process, that is heat is removed from the water. Cooling is done and saturated liquid is formed. The saturated liquid comes to pump and the cycle repeat. Then we will discuss about the process in Rankine cycles. The first process is isentropic compression in pump. That is, the water is compressed from a low pressure to high pressure isentropically in the pump. And this high pressure water when enter into boiler, it is heated at constant pressure. The temperature of the water increases and at a particular temperature, the temperature becomes constant and phase change occurs. So, dry saturated vapor is formed at the end of this heat addition process. This dry saturated vapor when entered into turbine, it undergoes isentropic expansion. During this expansion process, water droplets are formed, and at the end of isentropic expansion, the state of working fluid will be wet vapor state. Okay, this wet vapor is passed through condenser where it is condensed to liquid. That is, at the end of this condensation process, the state of working fluid will be saturated liquid state. Process 1 to 2 is isentropic compression in pump. The working fluid is pumped from a low pressure to high pressure. Process 2 to 3 is constant pressure heat addition process. When this high pressure water enter into boiler where it is heated at constant pressure by an external source, and the working fluid become dry saturated vapor. Process 3 to 4 is isentropic expansion in turbine. That is, this dry saturated vapor when enter into turbine, it undergo expansion and generate power. Process 4 to 1, that is last process is constant pressure heat removal process. Wet vapor formed after the expansion in turbine enter into condenser where it is cooled at a constant pressure to become a saturated liquid. And heat source used in power plants are usually nuclear fission or combustion of fossil fuels such as coal, natural gases and oil. And there will be a hot source. This hot source will heat the working fluid, and there will be a cold source which will remove heat from the working fluid. And the cold source used in thermal power plants are usually cooling towers and a large water body such as river or sea. And the actual vapor cycle differ from Rankine cycle because of its irreversibility due to losses such as frictional losses and heat losses to surroundings. And then we will discuss about the need of superheating. In this, at the end of heat addition process, the state of working fluid is dry saturated state, dry saturated vapor. When this dry saturated vapor enter into turbine, it undergoes isentropic expansion. During this isentropic expansion process, water droplets are formed. and at the end of isentropic expansion, the state of working fluid will be wet vapor. So this water vapor formed causes pitting and eruption in turbine blades. For avoiding this, we need to heat the working fluid to a superheated temperature. That is, the working fluid is heated to a superheated temperature, and the superheated working fluid is then supplied to turbine where it undergo isentropic expansion process. During this expansion process, water droplets are not formed, so pitting and erosion are avoided. Then Rankine cycle with the reheat. In Rankine cycle with the reheat, the expansion process in turbine is done in 2 or more stages. Before each expansion process, there will be a constant heat addition process. Let me explain. After the heat addition process in boiler, the working fluid become in superheated state, and the superheated steam is applied to HP turbine, high pressure turbine, where it undergo isentropic expansion process. After this process, the temperature and pressure of working fluid get reduced. That is, the pressure become 1/4 of the initial pressure, and the steam is again supplied to boiler where it is heated at constant pressure, and this heated steam then again passed through IP turbine, intermediate pressure turbine, where it undergo isentropic expansion. Okay, so Rankine cycle with the reheat will increase the work done in the turbine. Consequently, the net work done of the cycle will increase. Then Rankine cycle with regeneration. In this process, the expanded steam is extracted from the various stages or various points in turbine, and using this extracted steam, the condensed liquid is preheated. So here thermal efficiency will increase and the efficiency of the cycle will increase. Okay, thank you.